Hi there. In our previous chemistry video, we covered chemical equations, and you agree with me, this is a chemical equation right in front of you. Now, today we'll learn that this kind of chemical equation is called a molecular equation. It's called a molecular equation because all the compounds in this chemical equation have been written in their molecular formula. Today, we also want to take this molecular equation into another kind of chemical equation which we call the ionic equation. If you look at this ionic equation, you agree with me that this is the net ionic equation for this molecular equation. This is Z Online School. In this video, you and I are going to look at how to write ionic equations. We're going to do this in a systematic way. And so by the end of this video, you should be able to know what ionic equations are, the important concepts that you need to know before you start forming an ionic equation, and thirdly, we are going to know how to form ionic equations. At the end of this video, we've got some bonus tips for you. So make sure you watch this video till the end for you to get the maximum value from it. We are going to start with knowing what ionic equations are. Before we go any further, if you don't know what chemical equations are, you can check the description and watch the video about chemical equations so that forming these ionic equations can be easy for you. Now, if you have watched that chemistry video about chemical equations, you agree with me, a chemical equation is a symbolic way of representing a chemical reaction. So, ionic equations are those chemical equations that have something in them. There is a special kind of chemical equation that represent the ions that take part in a chemical reaction. After we know the compounds that are taking part in a chemical reaction, we can now form ionic equations. If we don't have the chemical equation, specifically the molecular equation, it proves very difficult for us to find an ionic equation for that chemical reaction. Now, before we go any further, it's important that we know what spectator ions are. Not all the reactants in a chemical reaction are very useful. Some are just there, and those parts that are just in a chemical reaction playing no chemical function are called spectator ions. The second thing we need to look at are the important concepts you need to know before we start forming these ionic equations. The first, as you can see, is knowing what gets ionized. If you don't know what gets ionized, I'm telling you, you get all your ionic equations wrong, because only compounds that are in aqueous state are ionized. If you don't know this simple fact, you will usually get your ionic equations wrong. We've talked a lot about ions, so it's very important that we get them out of the way. We need to know what they are. Ions are just atoms that have got an electric charge. And by electric charge, we just mean they are either positive or negative. Atoms in their elemental state are just electrically neutral, meaning the positive subatomic particles in the atoms is equal to the negative subatomic particles. Therefore, they are neutral. Now, ions come about when atoms lose electrons. For example, metals will lose electrons for them to have 8 electrons in their outermost shell. And when that happens, that particular metal atom will be called a cation. On the other hand, atoms that gain electrons are called anions, and usually these atoms are nonmetals. With that said and done, we can now start forming ionic equations. In this video, we're looking at 2 examples. These 2 examples have been selected so carefully that most of the things you encounter when handling questions will be sorted out. In our first question, we're looking at a neutralization reaction. Hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. After these react in this way, we are now asked to write the ionic equation for this chemical reaction. Where do we start from? Well, like I said earlier when defining what ionic equations are, The first thing we need to do is get the chemical equation for this chemical reaction. As you might have already learned in the video about chemical equations, we need to identify the reactants in this chemical equation and the products. As you can see, we've got hydrochloric acid reacting with sodium hydroxide. So these two compounds are our reactants, while sodium chloride and water are our products. So we're going to write hydrochloric acid. Remember, acids are those compounds that when are dissolved in water, they cause that water to become acidic. By becoming acidic, we just mean the hydrogen ions in that water have increased, and therefore that kind of solution will be called an acid. So acids are aqueous. The next we have is sodium hydroxide. Sodium hydroxide will also be taken to be aqueous. Why? Even if the sodium hydroxide that is gotten is maybe in pellets form or powdered form, immediately it is put into the acid, this sodium hydroxide will begin to dissolve. So sodium hydroxide can actually dissolve in water, and therefore we'll consider it to be aqueous. Now, this form sodium chloride and water. Sodium chloride is a salt and it's also aqueous. Water is liquid. Don't mistake it to be aqueous because the water can never be dissolved in water. Water is just a compound that has got a relatively low melting point, and therefore it's able to exist in liquid state at very low temperatures. This is our molecular equation. What we need to check for here is just see if it's balanced. I'm sure by now you've checked if it's balanced. If that time was too short, just pause the video and check if this chemical equation is balanced. Step 2 requires us to form a complete ionic equation. And by complete ionic equation, we just mean an ionic equation that shows us all the ions that are involved in this chemical reaction. Remember, we said we only ionize those compounds that are in aqueous state. The first element shown is usually the positive one, and so you really need to know the symbols of your elements when handling questions about ionic equations. This is to enable you not to mistake compounds like Na or H. You need to know that Na is for sodium and OH is for hydroxide. If you don't have that basic knowledge, it will be very difficult for you to answer such questions. So it's an added advantage if you check the video about chemical formulas linked in the description below. Since we are going to ionize hydrochloric acid, we know the first one will be positively charged and the second one will be negatively charged, and therefore we'll have hydrogen ion like that and then a chlorine ion. After that, we go to the next one, which is sodium hydroxide. Remember, hydroxide is a radical, so we're going to write it in this form. Hence, as you have seen, you should not only know the valences of your radicals, you should also know their charges. The good thing is that the charges are related to their valences. If you know the valency, for example, we know the valency of hydroxide here is 1. Now, we won't show that 1 here, we'll just put a negative. As you can see for the others, there's a positive, meaning sodium has the charge 1, chlorine a charge of -1, hydrogen a charge of +1. After that, we go to our product side where we're only ionizing sodium chloride. Water stays the same as it's not aqueous. This whole chemical equation we've written now is what is termed as the complete ionic equation. All the ions that are in this chemical reaction have been shown. Now, we said that the spectator ions are those ions that don't take part in a chemical reaction. Your job now is to understand how we can see which ions are spectator ions, because the only difference between a complete ionic equation and a net ionic equation is just brought about by the spectator ions. That chemical equation where we have the spectator ions shown is known as the complete ionic equation, while if we get out those spectator ions, it will be called the net ionic equation. So what we do in the third step is just cancel the spectator ions. Spectator ions are known to be seen on both the reactant side and the product side. And so if you pause the video, you agree with me that sodium and chlorine are spectator ions. So we're going to cancel them in this fashion. We cancel it on the reactant side, cancel it on the product side, just like that. This is to prevent any mistakes that you can make when cancelling. Sometimes you might think a certain ion is a spectator ion, but as you are cancelling, you find it's not. So this is to prevent you cancelling this whole complete ionic equation when you realize that you've made a mistake. Now, the ions that remain are what will be included in our net ionic equation. So you can see there's a hydrogen here and a hydroxy ion there. On our product side, you can see there's a molecule of water, and so we just write these three things and form the ionic equation, which is the net ionic equation. And we're done. As you can see, the procedure is actually very simple. However, this procedure might be made complex in many different ways. For example, you might just be told it's a neutralization reaction, you're given the reactants only, and the products are left to be found by you. Sometimes even these state symbols here are removed so that you can use the rules of solubilities to know the solubilities of the compounds involved. So even though this procedure is simple, the examiners might find ways of twisting this question and making it a bit difficult. Let's look at the second example. In this example, we've got a precipitation reaction in which silver nitrate reacts with magnesium iodide to form silver iodide and magnesium nitrate. Write the ionic equation for this reaction too. If you want to try this out, you can pause the video and work out the ionic equation, both the complete ionic equation and the net ionic equation. However, if you haven't yet gotten to that skill yet, just be patient and we'll get through this question too. The first step is forming the molecular equation, like you know. So here I'm going to write everything with all their state symbols to make everything simple for you. But when we look at salts and acids, bases, and salts, you get to know how to use all the rules about solubilities. Our reactants are silver nitrate, which will be written like this, and magnesium iodide, which will be written like this. Our products are silver iodide and magnesium nitrate. What we need to do before we get excited with forming the ionic equation is finding if this chemical equation, the molecular equation, is balanced. Silver has got 1 here, this side goes also 1, so it's balanced. Nitrate, or we can go with nitrogen. Nitrogen has 1, this side it's got 2, so we know nitrogen is not balanced. Oxygen is also not balanced because they are of the same compound here, which is nitrate. Magnesium has got 1 on both, so it's balanced. Iodine is also not balanced. If you've watched the video about chemical equations, you agree with me, you look for hints in this chemical equation. Right from the start, what I notice is that the nitrate here has got 2 outside the brackets, while this side there's nothing. So that's an indicator for me to know that somewhere I need to put a 2 that will enable nitrogen to have 2 atoms and oxygen to have 6. The easiest to do that is just adding a 2 before silver nitrate. And when I do that, you can see that this causes something to change in this chemical equation. There's no longer 1 atom of silver, there are now 2. Therefore, it becomes very easy for me to notice that I also need to put a 2 before this silver iodide. And now I try to check if this chemical equation, the molecular equation, is balanced. If you use that time to check, I'm sure you've seen that this molecular equation has balanced. Now let's get to form the complete ionic equation. We're going to start with silver nitrate and go till we reach the last compound we need to ionize. In silver nitrate, we've got silver itself and nitrate. Don't mistake this to be nitrogen and oxygen in their separate forms, as this is a radical here. Silver in this case has got the valency 1, as you can see. When it bonds in this fashion, we can tell that the valency of silver is 1. Now, what you also notice that I've put a 2 before the ion for silver. Why? Because this 2 is affecting each of the ions part of this compound. And therefore, when writing, this 2 will affect each ion I'm writing. Okay, we are done for silver nitrate. Now we try to write magnesium iodide in its ionic form. We've got 1 ion of magnesium there, so it's very simple. Remember, magnesium is a group 2 element, so it's got the valency 2, and therefore we show it as 2 plus. Now, another question comes about iodide, or how are we going to treat the ion for iodine. You can see there's a 2 here representing that in this compound we have got 2 atoms of iodine combining with 1 atom of magnesium. In such cases, some people might write it wrongly. They'll put an I, a 2 just like this, and put the charge of iodine just as the superscript there. Now, what you need to do is this. All these numbers of these atoms will be taken as bigger numbers like this. So for iodine, we are going to write it like this. As you can see, this is actually a very simple thing. But if you forget it, it will cost you an entire sum of marks. And so always remember that you should work with compounds that have got such atoms being bonded together in this fashion. Now we go to the magnesium nitrate. Don't try to ionize this because, as you can see, it's not in aqueous state. It's in the solid state. Therefore, we go straight to magnesium nitrate. As you can see, we've got magnesium there. Magnesium is in group 2, and therefore we're going to write it like this. Then nitrate. How do we write nitrate? Just like we handled the iodide here, or the iodine ion, this is how we're also going to handle the nitrate ion. We're going to write the chemical formula for nitrate and put these 2 before the nitrate, just like we do in balancing. And we're done. As you can see, from this molecular equation we now have this chemical equation, the complete ionic equation, with the charges for each of the ions in the chemical reaction. Next, we look for the spectator ions and cancel them. Magnesium is on both sides, nitrate is on both sides. So we look here, we cancel on our product side and do the same for magnesium. Then we write our net ionic equation, which is the equation involving only the things that are remaining. Nice. This equation that we have now is called the net ionic equation. These 2 examples must help you understand the procedure of forming ionic equations. And you should also know what complete ionic equations are and what net ionic equations are. Now, you have reached the bonus tip section. Today we've got 3 tips for you. The first is about the general format for an ionic equation. For many questions about ionic equations that you'll be given, the net ionic equation has the following format, as you can see. There will be 2 ions here, probably a cation and an ion. Then we'll have a substance that wasn't ionized. So it might be in solid, it might be in liquid, or it might be in gas. However, as you can see, I use the word many here. Not all the questions you'll be given will have this format. There will be some where you have 2 ions and another ion on your product side. But most of the questions you'll be given will follow this format. 2 ions and a non-ionizable substance or compound. Try out these 2 examples and see that truly That's the result. Hence, this tip helps you really be fast when forming ionic equations. Specifically, when forming net ionic equations, you have the added advantage of knowing what will remain, because immediately I see there's a substance that I can't ionize, like in the first example where there's a solid, I know the ions that must be left on my reactant side must be a copper ion and a hydroxyl ion. The same applies to the second one. The next tip is about radicals and their charges. It would be pointless for you to watch this video and not get these radicals and their respective charges. In this table, you can see different kinds of radicals. For example, ammonium, nitrate, nitrite, hydroxide, and many other radicals. As you can see, most of them are negative. At the start, you saw we used a chemical equation that involved ammonium, and you saw how the net ionic equation came out. For that particular one, it's that kind of exception where our product is also an ion. The last but not least is the mass non-solubilities of some common compounds or salts. In this table, what you're going to find are those things that make a salt soluble and those that make it not soluble. On our left part here, which is green, we've got the soluble salts. Any salt of group 1 is soluble. Any sort of ammonium is soluble. So think of ammonium chloride, it will be soluble. You don't even need to think about whether it won't be soluble. Therefore, it will be able to form aqueous compounds. And so this table generally is what you use if the state symbols are not given to you. As you saw, we had sodium chloride in our first example. If you look at sodium, sodium is in group 1. And so sodium chloride will be an aqueous compound. However, if we had something like barium carbonate, it won't be soluble, because as you can see, all carbonates are not soluble except carbonates of group 1 and carbonates of ammonium. So if we have ammonium carbonate, we don't even need to debate. It's soluble. Thanks for watching this video till the end, and now try to get practicing to see if you know how to form ionic equations.